Assalamu alaikum. For today's video, I will explain how to do PERT, which is Program Evaluation and Review Technique. This time I will be explaining in English, hopefully for some non-Arabic speakers could understand from today's explanation for the PERT. So previously we learned the critical path method, which is, let me show you here, not communism. It's this. We learned the node way, and the node didn't represent the activity. The arrow represented the activity. But this time we will learn how to do this, and we will learn how to do how to calculate some probabilities also with it. Okay. So for now, how we estimate for the duration of times, we have an optimistic duration, a most likely optimization, and a pessimistic. Optimistic is like the best case. Pessimistic is like the worst case, and the most likely is this thing that will most likely happen, just as said. Before we start, let's try to find the expected and the variance for each task. And to do so, we have simple rules for them. Now we should know that we should memorize those rules actually. So a good way to try to memorize the equations is to understand where are they derived from. So this is the normal distribution graph, and from probability you might know that there's like some unit of measuring where you start from the mean, which is 0, and then each step is like 1 sigma. So you go 1 sigma, 2 sigma, 3 sigma. And for going 1 sigma to the right and 1 sigma to the left, for the distribution area, it takes 68% of it, which is about 4 out of 6 as a fraction. So to connect the dots, we want to somehow represent the optimistic and most likely and pessimistic durations to this standard deviation. So since most likely will most likely take the chance, we will give it the 68%. Now we have the rest percentages from the right and from the left. So to the right we will give it the pessimistic, and from the left we will give it the optimistic. So the most likely will take 4 out of 6. The optimistic and the pessimistic will both take 1 out of 6. So we have 1 out of 6, 4 out of 6, and 1 out of 6, which is if you sum them together, they complete like one whole fraction. Therefore, we have the following equation. So to find the expected, which is basically the mean for this probability, we give the probability of optimistic plus the probability of most likely plus the probability of pessimistic, and you multiply them by each value. So this one shortly gives you the following. So to simplify it, we finally get O plus 4m plus p divided by 6. This is the equation to find the expected. Now what about the variance? Simply put, the variance is pessimistic minus optimistic divided by 6, and you square them to find the variance. Now why is it like that? To be honest, I'm not entirely sure. I hope you could memorize this one easily, and you understand why we have 4 here. It's because it's taking 4/6 of the standard distribution. Now with those rules or equations, we can easily find the expected and variance for each task. For example, here if we want to find the expected for A, we add the optimistic plus pessimistic plus 4 times most likely. So it will be 2 plus 6 plus 4 multiplied by 4. We find the sum and then we divide it by 6, just as this. You add 4 of the most likely and you divide it by 6. So we will have the number 4, and we continue for the rest tasks. Now I would like to keep in mind that we will be working with 2 significant figures to the right. So and we want to estimate. So if we got like 5.167, we will estimate the second digit from the right, 6 to 7, because estimation. I hope you know how to round. Now we got the same with the variance, which is pessimistic minus optimistic divided by 6, and you find the square root for it. So we here we have 9 minus 3, you divide it by 6, and you get the square root. So we get 9 minus 3, which is 6. 6 divided by 6 is 1. 1 squared is 1. So as you can see here, I calculated for the rest values, and we found the expected and variance for all tasks. Now we can go on and make the PERT nodes. Now our doctor suggests that before we start with drawing the nodes, we try to visualize so we can know how we can put each node. From what we see here, we can start with A and B since they do not depend on any task. So we expect that A and B will start first, and then we could go with C and D, which both depend on A, so they will be like near A, right? And then we can go with E, which depends on B and C. So we expect that B and C, they will have they will share another box for E, and then we expect that D will connect to F here, and finally we have E that will connect to G. Now we can try to make start with the diagram. Before we begin, I would like to show you what each box represents for this node. We have here on the top left, we have early start. On the top right, we have the early finish. Here we have late start and late finish. Sorry. And from above we have duration, and below we have the slack time. So just like the critical path, we have a start node, and it starts with 0, and you could add 0 here also. Let's go now with adding A and B. We have here the duration for task A, which is the expected value. So here we have 4, and for B we have 5.33. 5.33. Okay. Now as you can see here, I made for the rest nodes. If you notice here, I made D above and C below because we will connect B and C together. That's why it's important to visualize, just to not erase your solution, like waste time in erasing and making sure the nodes are correct. Try to make a simple maybe box for A and B and C, and then you go with making the PERT boxes. Okay, now I filled the duration for all nodes. We can go and start with filling the start, the early part, early start and early finish. With the early part we go forward, and with the late part we go backward. So we will start reach with each node and try to reach to the end, and then we will go backward. We could start from 0 here, and we need to fill early start here. Now to fill it, we just need it is equal to the previous early finish. So this early finish is 0, so we will fill here 0, and also we will fill here 0. Now to find the early finish, you just add the early start with the duration. So it is equal to this plus this. And now we go on and we do the same for everything else. We will add here 0 plus 5.33, which is 5.33. Here we add 4 for each one. We add 4 plus 6.3, which is 10.33. We add 4 plus 5.17, which is 9.17. As you can see here, both arrows point to this node, and we have two choices. We have 9.17 and we have 5.33. So we need to pick one. Now you should, by common sense, if you think about it, you cannot start this task unless you finish both tasks. So we need to ensure that both tasks have finished. which means we will take the maximum duration, which is here 9.17. Sorry, we need to take the maximum late start. So here it is 9.17. I need to correct myself again. It is early finish. We need to find the maximum early finish for those nodes. We have 5.33, we have 9.17. So we will take the maximum, which is 9.17. Of course, we will add this to this and we will get the sum. As you can see here in the end, we have both values, and we will take the maximum, which is 19.51. Now we finished the first part. We need to go backward. For the ending, you will realize that it will be the same value that you put for early start. So here need 19.51. 19.51. This lag here will be 0. Also in the start it will be 0. Now we need to go backwards. So let's just go backward now. When going backward now, we need to start with the finish instead of the start. So from here you take the number 19.51, which is taken from the end here, and we take here 19.51. Now to find the late start, for going forward, we added early start plus duration to find the early finish. Now to find the late start, you will take the late finish, you will subtract it by the duration to find the late start. So here what will it be? It will be this value minus this value, and we get here 14.34. And we do it for the rest. Now you notice in this part we face the same issue we faced in going forward, which is we have here two candidates. We have 8.68 and we have 4. So which one do we need to fill it? Now going backward, instead of taking the maximum, you take the minimum. So we will take the smallest value here, which is 4. And then you have 4 minus 4 equals 0. And now we have here the same problem. We have 0 and 3.84, and obviously we will take 0. And of course, since it is the start, everything should be 0 here. So I think that if you didn't get 0 here, it is a wrong calculation. But I'm not sure about this one, if it is correct or not. But by common sense, it should be logical that this should be 0. The minimum here should be 0. Okay, now after we are done, we have the final step, which is to find the slack time. To find the slack time, you subtract two values, and those values could be either the late finish and early finish, or late start and early start. Let's go here, for example, with G. So to find the slack time, you will subtract the vertically. So 19.51 minus 19.51. It will give you the same value that you would get from subtracting on the left here. So which here will be obviously 0. This also will be 0. Now for this one you need to calculate it. So 19.51 minus 14.83. We will get this value. For this one it will be this value here. We'll get 0. Let's subtract this one, and we should be done here. Of course, the goal of making this is to find the critical path. To find the critical path, you will go with the one that will have the slack time of 0. So we have A, C, E, G. So the critical path we have here is A, C, E, G. Now I highlighted the critical path because we will need to distinctify and solve other questions for them. Okay, for the first question, we need to find the expected and variance for each task, which we have already done. We have found them for each task here. The second question will ask you to find the PERT diagram, which is this one, and we have found it and completed it. Now the third question will ask you to find the total slack time, which basically you will find the sum for all of these values in the slack. Of course, since the critical paths have 0, they will like make no difference if we add them. So we will add those values to find the total slack time. After summing them, I found that the total is 13.2. We need to find the critical path, and we found it, which is ACEG. So we could do like a ACEG. To be honest, I'm not sure if like formatting it definitely will be wrong. Like, do we need to make it like this? I don't know. I hope like the doctor is not as critique as this, because this is usually how I do it. Now for this question, we need to find the project mean time. To find the project mean time, you basically need to find the duration. To find the expected, which is the duration actually, for each critical node, and we find the total. So if we go back here, we have, what do we have here? We have we have 4, 5, 5.17, 5.17. You find the total, and this will give you the mean time. Now we need to find the project standard deviation, not the project variance. So we go and for each critical node, we go back to the table and find the variance for each one. We find the sum, and then we get the square root for them. Okay, so just to make it clear, we get the variance for A, C, E, G. We get the sum, and then we find the square root, and we get this value. Now for the last 3 questions, they will be about probability. The probability to find that the project will finish 3 days after project time, or 3 days, before the project time, and 3 days less or more than the project time. Now in the exam, we will be given a table like those, and from them we will be able to get the probability. Now for this, this table, you need to find a value called z, and to find it, you need the following equation. To find z, you need to get x minus mu over sigma. So let's get the following. What is x here? If you notice here, it is 3 days after the project time. Now x will be the project mean time plus 3, which is 3 days. So 19.51 plus 3 will give us 22.51. And mu is just this mean time. And sigma is the value that we found, which is 1.28. So let's put them together. Now if you notice here, we have like x, which is, the mean time plus 3 days minus the mean time, which will give you in the end only 3. And you divide it by sigma, and in the end we will get the value 2.34. Now this z value, we need to get back to the table and find the probability for it. Now going back here, here is how to navigate a table. We have this table here, so it will we will go from the y-axis to find the first 2 digits. So we have 2.34, so we need 2.3, and then we need 4. So we will go to the right. Here is 0, 1, 2, 3, and 4. And we have the following probability, which is 0.9904. So here in the end, we get that the probability after 3 days will be 0.9904. Now to find it before the project time, someone might conclude that it is, since it is before, you will just subtract it by 1. But let's do it like this way. Since it has almost the same values, the only difference here is that since we are going before, we need to subtract by 3, and then we will get actually a negative value, which is what? It will be minus 2.34. Now we go back to the table and we find one that has negative values. The pictures are getting smaller and smaller, but in the quiz you will get like a big one. So here we have minus 2.3, and we go and we find that it is 0.0096. So for this one, we have h equal 0. What the value did I say it was? 0096. And if you noticed here, it is actually like the difference from 1 here. Like if you do 1 minus g, you will get actually this value. Now finally, to get 3 days less or more, it actually depends on those two values, and you need to get the difference between them, which is basically you get the absolute. Let me just do it. I'll take a while. We need to get the absolute here. Where is the absolute subscript or whatever it's called? Finally, we get this value 0.9908. So the probability that we finish in 3 days is very likely, as you can see here. So this is it for finding PERT and solving some probability questions. I hope that I got the correct solutions and I explained everything correctly. Please, if anyone is watching and noticed an error, please notify me. And good luck to everyone in the next quiz or exam.